initialize that repository and we made a local changes, right? Okay. So we'll see the in detail information about the Git and the version control system, and those part we'll see today. And parallelly we'll create the remote repository, which is nothing but a GitHub. Okay. And I forwarded that script, password script working, right?
I didn't check it.
It's working, I checked it. Okay, check once.
What's the difference between GitHub and GitLab?
Okay, totally different concept. So GitLab, what happens is, it is basically used to manage the CI/CD pipeline plus version control system. Earlier, GitHub was open source, managed by the same organization. After Microsoft acquired the GitHub, they started the GitLab. So GitLab is a simple tool where you can manage the source code, pipelines, deployments. Everything you can manage.
So these features was not there in the GitHub.
GitHub now they introduced it called GitHub Actions. You can see even that one also. Okay, you can avoid Jenkins, use the GitHub Actions.
So which is more useful in the organization? Like which organization, which one they are preferring, GitLab or GitHub in today's market?
Depends. GitHub is just only source code management. GitLab is a commercial license where you can manage the source code, pipeline, and all those things. Okay. Fine then. So last class we saw this difference, the version control system between the centralized and as well as the distributed. Centralized is the old method which is using by the SVN. Distribution version control is the main method which is developed based on Git is developed based on this distribution version control system. This is the very basic fundamental difference. Someone want to check your fundamentals, they'll ask you this part. Not Git commands, not GitHub or functionality. This is the backend. Based on this distribution version control, Git was developed. It's open source. Based on that one, only GitHub was developed. GitHub is what? It's a cloud-based one. Git is not accessible remotely. It's a generally local one. Of course, you can create remotely also, but within an organization only. But if you want to make it globally, means via public, then GitHub is introduced, which is a cloud-based one. Okay. Then after that, Bitbucket was developed, and even what is that? GitLab, that one also developed. Same, all are working under the same distribution version control systems only. Okay. So this is the main thing. Here, maybe you can follow this documentation. This is the standard documentation, and here this is the main difference. You can see. This is the interesting part. So assuming that in your repository you have 3 files, file A, B, C. Okay. First you see the first difference. So what is happened? File A, version 1 I have, file A, B, C I have. So in version 2 means each change we can treat as a version. First commit, first version, second commit, second version, like that. Okay. So version 2 what happened? File A become as a delta 1, means I made some change, delta 1 change I made. File B as it is, no change. File C as a delta 1, I made the first changes. Version 3, so file A no change, file B also no change. File C become delta 1 to delta 2, second change. Version 4, delta 1 become delta 2, and file B as a delta 1, and file C nothing. Version 5, no change.
No sound is coming.
Okay. So version 5 you can see file B become delta 1 to delta 2, and file C is become delta 3. This is what our assumption where the changes will happen on each commit. Why? Because in a repository you have 100 files, but you are making change
So
in
no
only.
voice is coming.
Your voice is very low.
Voice is not coming up. What about others? You are able to hear?
I can hear clearly.
Yeah, thank you. Who are not able to hear, please rejoin.
I can also hear.
Yes.
Yeah, thank you guys.
Yes, there must be some network issues from
Yeah,
their
yeah.
end.
Yes, okay, so our assumption is this is what our assumption. Generally, the files will be changing the versions like that, but it's actually wrong. How it work majorly? You can see the second method. This is the method we have. So version 1, we have file A, B, C. Version 2, what happened is file A become as A1, means I made a change. File B become as a B only. File C become as C1. Now see the difference between the above one and this one. Above one, what happened? We are assuming it is empty space. File B, you can see. But here it is treated as a file B. So when you have hundreds of files in your repository, you are making a single file. Don't think that your repository only concentrating the changed file. Got it? It will look for all the content in that repository. So it marked as a B as no change in that particular commit. This is very important. Why? Because now assuming that in future you want to revert the code back, somewhere it will happen. Generally, last week that was the discussion with my developer. Some codes were not happened. We need to revert back the code. So what we have to do there is we need to revert back the code. Assuming that you are in a version 3, you want to revert back to version 2. In previous model, what is our assumption? There is no change in this file, but there is no reference. Got it? There is no reference that file has changed or not changed. Changed one, maybe you are marking delta 1 to delta 2, but file which is not changed, there is no reference. When you revert back, this is the problem. So the main model is, you can see the below model. So file B marked as a B only, no change. Next version 3, you can see A1 become as A1 only, no change, and B become B only, no change. C1 becomes C2, change is there. Again, version 4, we have a A1 become as A2, change is there. B become B1, change is there. C2 become as C2 only, no change. So in each version, on each commit, it will be track each and every object change. That is what your version control system will work. It is not that I not made a changes in other file, it will not track. No. This is the model, it will happen basically. Okay. So whenever we make the changes, this is what it will do. Okay. So keep this in mind. This is what the snapshot of the project over the time, how it will happen from one version to another versions. Okay. Next.
So when we do a commit, it will not give you the version, but it will give you commit ID.
Commit ID, that is nothing but your version.
Okay.
Each versions. That versions only it will store in your Git database. .zip directory, all your commit history will be there. Okay. That will be created with your commit ID. See this commit ID. It is a SHA commit ID. It will be auto-generated on based on the timestamp and the repository. It will be generated. It is unique. It will not match with any ID generally. Okay. So now coming to the Git, we have 3 states. Okay. So first one is the modified state. Second one is the staged. Third one is the committed. 3 states. So what we did first, we initialize the repository. When you initialize the repository, our repository is clean. Then after that, we made a change. With that changes, it created some modified files or the created files. That is nothing but your stage area. Then after that, we are added that files and committed the changes. Okay, you can see those 3 areas. First one is the modified state. Some content is modified or updated, anything. Second stage is stage. Stage area means you modified, you added the files, but not committed. That area called as a stage area. Stage area you can able to revert back. if you don't want. Stage area is the area which is ready to commit. That is a stage area. It shows that files are added, ready to commit, like that it shows message. That area we are calling as a stage area. Next one is committed. Means what are the stage area, what is committed files are there, it's ready to commit. That is a committed area. Once you committed, your repository is up to date with the changes. So these are the three areas. Generally in intro, they'll ask, what is a stage area? Stage area is the area where you have the files are updated or modified, which is ready for the next commit. Okay, so in the stage area, we have all the files which added files, removed files, modified files, whatever it is there. It's tracked. That comes under the stage area. That is ready to commit in the next area. So your Git repository, so check out your fixes in our working directory. That one we are getting the stage area, which is making your intermediate changes are committed, whatever the things are there in there. So which is ready to commit for the next commit. That is whatever repository areas. Okay, these are the three major areas. Clear? Next. So installing Git and all I showed. Anyone has any difficulty, let me know. It is a simple download installer for your Windows or Linux, Mac. It's not a big deal. So it's a graphical mode. They're showing how to install and all those things. This is what we can do. Okay. So once Git is installed, the first part in the Git is you have to configure your account. First time setup, you need to do the Git configuration. So you have to set your username and email address, because who is modifying my code? I want to track. Okay. So last class we saw that locally created repository. Now I'm not doing locally. I'll create a remote repository, which is from the GitHub. Of course, we created already, right? The repo.
Yeah.
Okay. Meanwhile, you guys send me your GitHub IDs in the Skype link. I'll be adding you guys. Some people sent, some people I added, some people I didn't add. So this is GitHub, which is a cloud-based one. You can accessible this one globally from anywhere. And you can able to control it based on the permissions, whether it's a public or private repository. So I created a repository, DevOps 6 PM. This is what the repository I created. So you can see that this is a public repo. Okay, this is a public repository, can be accessed by anyone. Okay, if you guys want to access it, so copy this link. See that someone made a commit. Cloud user, it seems. Who is this cloud user? I ask not to disturb the main branch. Don't disturb the main branch, okay? Let me get the link. Copy the link. Okay, so you can clone this repository and you can start making the changes in this repository. So now what we'll do is,
How to provide the access to the users?
yeah, now that is the reason I ask you guys to send me your GitHub IDs. Okay, then what I'll do is I'm deleting this file. Okay. So I already gave this one permissions, some of the collaborators. So I gave some of the users. She not even accepted the invite. So these guys they made. Okay, fine anyway. So let me add the people. So then you'll get an access. Let me add.
You have to give entire email address or just
ID, GitHub ID is enough for me. Yeah, it's pick it up. GitHub IDs.
We need to create this while going into the GitHub website.
Yeah, you have to create it and send me the ID.
Once you create it, the invitation will directly go or we'll have to push the invitation.
Yes, you have to accept the invitation. Then you can clone this repository and you can start pushing the code. Otherwise, you can't push the code. You can able to get this code. I mean, repository can get it, but you can't push the code changes. Okay. So fine then. Let me. I already cloned this repository in my local. Okay. So how to clone this one? We'll do it anyway again. So first thing is copy your repository link. Okay. So under the scripting, I guess I cloned already. I cloned here. Okay. Now nothing is there. I'm cloning again separately now. So run a command called git clone. Git clone and repository URL. This everyone can do because my repository is a public repository. So not a problem. If it is a private, no. You have to authenticate even for cloning itself. Okay. So it's cloning. Yes, fine. So let's go to the DevOps 6 PM repository. Fine. And by default, you will get a branch called main branch. You'll get it. Okay. What is a branch here? Branch is nothing but a logical separation of your repository. Very important. We have to discuss our branching strategies and all those things. Based on that one only we can able to manage. Okay. So this branch right now, main branch, remember this one, we'll discuss further how to create a branches and all. And even I can see the other branches also. Some created Gopal or main, Sam, Vishnu, all those branches. So what you have to do is you have to create your own branch after cloning this repository. Don't make any changes in the main branch. Okay. If main branch you made change, that will reflect to all other new folks whoever they created the branch. Don't do that one. Okay. So fine. Now here see git log. You can see the all your what is that commit IDs. Maybe if you want to see in detail information, git log -p. See that in this commit ID as this user, what I did, I see that deleted a file, that test file is deleted. And in this commit ID, some cloud user, so he not even configured his account. I don't know which user is this. Okay, it is from EC2 instance. They committed the changes without config. You have to do the configuration first part. Git config your user.name, user.email you have to do. Otherwise, by default, it will take our current system user IP address and the host name and the username, login username it will take. And with that one, it is committed. So some file is created. Git diff new file is created. Test. Like that further commits you can see I created some directory structure, something I created. This is what I did. And something file is updated, something I created a new repository, all those things. Okay, so we can track that in detail information. Okay, now let's see, we'll make some change. I'm making some change. We discussed Linux now. So under the Linux directory, I'll make some change called touchscript.sh. Okay, I created a file called script.sh and I'm writing you have to create your own branch and you have to update your scripts under the Linux directory. Okay. Okay. So I'm saying, for example, even we don't do this. Okay, let's see that git status. Some file is did. I don't want this. Git stash. Okay. Now see, it's not there. So let's do remove it. rmscript.sh. Okay. So as of now, I have nothing is there in the main branch. I'm creating my user branch. So how to create a branch? Git branch Vishnu. Okay. So once you say that the branch will be created here, already branch is there. So git switch Vishnu branch. Okay. Here already there branch. Here I'll update under Linux directory. I'll create Linux script.sh. So I'm editing under Linux script.sh, saying that bin bash echo. I'll simply say that hello from git. Okay, because local, I'm calling local one as a git, remote one as a GitHub. Fine. So now see git add Linux script.sh. So modified stage 2, I came to git stage area. This is called a stage area. So the stage area is ready to for the next commit. So git commit -m. I'm giving a message that added shell script. Fine. Okay. This is what I have to do. So I committed now. But if you see the status now, what it's saying on branch Vishnu, nothing is commit, working directory is clean. But you have to do git push. Remote already Vishnu branch is there. I don't know why it is saying set. Okay, anyway, let's see. So I'm setting a branch called Vishnu. You have to run this command. Generally push means pushing your code to remote repository. But remote repository Vishnu branch is not there. So what you have to do is you have to set upstream. Upstream means in remote you are setting the upstream. The origin is Vishnu. So copy this and enter. When you enter this one, okay, it is rejected. Why it is rejected? So here the problem is there. I guess git pull. I know this is the problem. So this is the problem. I said now remote already branch is there. Okay, here see the message. Now the branch is rejected to push my code changes. See the reason. Failure to push the references to the remote repository because your current branch is behind your remote. I said now if you want to push the changes, your heads must be equal. Locally head is not there. Why? I created branch locally, but already Vishnu branch is there. I have to pull. Okay. So do git pull. Okay, so try git pull once. See that is what the merge conflict happened. What is the conflict now? I made something locally change, which is not up to date my local repository with the remote changes. Now I'm trying to pull in the changes. Now I got a conflict. This is resolving automatically because there is no conflict in the same content. I have a local change is the different change. Of course, same branch, but different change. Remotely different change. So while pulling local change and these two changes are conflicting, it is resolving automatically. Let's make the change. Fine. See that again, do the git pull. It's up to date. We don't have any change. Yeah, there's maybe some changes in the local rebase. See the git status. See that on the branch Vishnu, your branch is ahead of the 4 commits. Git push. Okay, local changes I made it now, it is reverted back with my pull. So you do git push. Yes, it's up to date. Actually, when you do git push, you have to authenticate also with your git username and not password. You have to generate your this one. Go to your account. Under your account settings, you have to go to your developer settings. And go to personal access token. And here tokens you have to choose. And here generate the new token. I already used one token. And while you are creating a token, don't forget to give the permissions. Here you have to give these permissions. Once you give permission, the token will be generated, one normal token. With that token, you have to do the authentication. When it is asking for the password, you have to give the token. Then it will be authenticated. You can able to push the change. Okay. So that is what you have to create your branch. Now you see the difference with respect to the branch. Okay. So in my local, I'm doing fetch. Okay. Why I'm doing fetch, I'll tell you. Now see git status. Nothing is there. Git branch. Git branch -r. See that remote -r represents remote branches. It's showing Gopal, main, Sam, Vishnu, some branches it's showing. Okay, fine then. So now let's see. I'm in the branch Vishnu. In the branch Vishnu Linux directory, I have a script.sh. Right? Let's switch to main branch. Git switch to main branch and do ls Vishnu. See that script.sh is now same repository, but two different branches, two different kind of structure. So branch 1 and branch 2 won't mix at any cost. That is what I said. It's a logical separation of your repository where this can be useful. Think that you are developing an application. You are an application developer. You are developing an application 1.0 application. For example, when you develop a 1.0 application, fine. You are developing in a repository with the current branch 1.0 you are developing. You release it to the customer also, fine, not an issue. Now 2.0 you have to develop. To develop 2.0, again you should not disturb 1.0 code. This is the principle. Why? 1.0 code is developed, built, released to the customer. It is in use, production use. Tomorrow something happened wrong with that application, we need to refer this code, but we should not change 1.0 code. On top of 1.0, you have to develop the 2.0 code. 2.0, what is there? Your new features will come into the picture. Example, 1.0, you are creating entire code related to some X features. 2.0 next release, you have to upgrade your code changes. So what you will do, without disturbing 1.0, you have to develop the 2.0. Then we'll copy 1.0 branch to 2.0 branch will copy. That is called merge. Merging entire code 2.0. Then you start developing on the 2.0 branch. My developers will be working on the 2.0 branch, not 1.0. Because 1.0 I locked it. Means it is released to the customer and it is in the production. If any bugs are there, features are there, they start working on the 2.0. That one same thing will be going for testing, same thing will be releasing to the customer. That is what the branching can able to help you. No mixing between the 1.0 2.0 because two are different features. I'll not mix it. In that scenarios, it helps a lot. That is what branching strategy. Anyway, I'll tell you that one separately. Okay, as of now, remember this part. Now commit your changes in your own branch with all your Linux scripts. Then this branch, I mean this repository later on will integrate with our Jenkins pipeline. Whenever you will make changes in your local source code, Jenkins job will be triggered and it will be running automatically. We can do that one. Today interview also they asked the same thing, that how to write the Jenkins pipeline, how we'll make auto triggers, all those things. Okay. Anyway, that's fine. So this is the main branch. Let's come to, maybe you can try git pull again. If any code is there, it will pull. As of now, nothing. So again, I'm switching. So latest command switch is working. This is the latest git repository. If old git versions are in my local environment, my production environment, switch won't work. I have to use git checkout branch name. Switched git branch. Checkout also you can use. Olden days we used to use checkout only. Latest one switch is working. Okay. Clear? Any doubts?
You create generally in practical what we are doing, creating branch means we are making a change in existing repository.
Existing
just for a
repository.
track, and then we commit, then it will all changes merge to a main branch.
Main to your branch will come, but
Yeah.
your branch to main it will not match.
Last commit, whatever changes we did in our new branch, it will go to the main branch, right?
No, it will be in your branch only unless you do merge manually or explicitly. Otherwise, no.
Okay. Last we have
All branch are independent.
Right.
It will never merge unless I'll merge if it is required for myself. Otherwise, no. Your branch is like an independent entity for yourself within that repository. Okay. If it is required, we can copy from one branch to another branch. That is what our branching model. That is what we are calling as a logical separation of your physical repository. When you enter this floor, this room is different from that room. There is no connection. This is logically separated. It's not mixing both. So your branch is independent. Branch 1 is independent from branch 2. Okay. That is the reason main branch code is not there in the Vishnu branch. Vishnu branch code is not there in the main branch. But if you guys will create a new branch now, it will came as it is from the main branch, whatever it is there, that will come. Okay. Clear?
If you do merge here, then readme.txt and script.sh will come together.
Yes, if I merge from Vishnu branch to main branch, if I merge, then it will come. Merge is nothing but copy. Merging the current branch commits to master branch. That is called your merge. Okay. So generally merge means say copying of your commits from one branch to another branch. We'll see anyway merge concept in further. Now you guys will be clone this repository and start creating your branch and then push your scripts under the Linux directory under your branch. Okay. And if you want to push this one, first thing is I have to add you as a collaborator. Send me your GitHub IDs. That is the first thing. Second thing is you have to use your authentication model with access token. Then only you can push the code changes. Okay, that is what remote repository. Now this is not local. Example, let me show you one difference now. Now I'm in Vishnu branch, right? Right? Okay. So I have a Linux directory script.sh file. What is the latest commit? Echo hello from git I did, right? Let me see the difference. Let's go to the remote repository. See that recently Vishnu branch added changes. So let me switch to, if I want it, I can create a pull request, I can merge to main if I want. I don't need now. Let me go to Vishnu branch. Okay, see that Vishnu branch under that Linux directory script.sh file is there. Okay, hello from git is what I updated from my local, right? Okay, now see the difference. I'm updating from the remote. Maybe assuming that this code is modifying by she is modifying from her local repository, she updating it. Okay, just assume. So she modified not from Git, it is from the GitHub. Okay, I'm just mentioning this name by I'm mentioning. Okay, correct spelling. Okay, fine. I said that updated. She logged into my branch, just assuming that we work at same together on one branch, just assume. So updated script by her name I mentioned. Okay, just for our reference. Okay. Okay, now you can observe the difference. What is the commit ID here? See the latest commit ID. Latest commit ID is 7897C9. Right? Now you see the local commit, git status. Everything is clean, it's saying. Right? And what is the git log commit ID? AD0. My current local head is AD0 head, remote head is 70 something. Definitely both heads are different, right? Now see, I'm trying to make the changes in the same file, same line, same content. Got it? Generally earlier what happened, if your commits are not updated locally, it will reject, saying that first you pull, because your commit is behind the remote, you have to pull, then only can push. Otherwise it will not happen. That is the mechanism for your distribution version control system. Now I am not familiar that she made a change remotely. Now what I'm doing is same file, I'm modifying that, saying that by Vishnu. Right? I'm doing it locally in the Git only. Okay, I not disturbed the GitHub level. Fine. I modified and I'm saying git add, fine, and git commit, saying that updated locally by Vishnu. Okay, this is also okay, not a problem. Now let me push. You can see the difference now. Git push. Okay, what is happened here? Rejected. My push is rejected. What is the reason you see? So updates were rejected because the remote contains work that you don't have locally. Very simple. This is the mechanism. Okay. So for this purpose, what you have to do? You have to do first git pull. Right? Now you see the difference. Okay. See the difference. It is rejected. Just a minute. Okay, see that what is the difference here? Auto merging not happened. You remember earlier auto merge happened. Earlier we have auto merge happened because which I not pulled before that one. I made some other change. That time content was different. Two different files. No conflict. Now you see the difference here. Conflict of content. Merge conflict in Linux script.sh. Auto merge is failed. Auto merge not worked. Why? Now Git is in confused state. We both edited same file, same line, same content. What need to take? So merge is not happened. You can see now Git status. See that. What happened? Script.sh is in a modified state. Right? Now take Linux script.sh. See that head and commit ID, you can see the difference. So what is the head it's showing? Head it's showing my local head. Commit ID not created. It's reverted back my code. And below that, what is the commit ID came? It's already committed. It's updated in the remote repository database. That is the main thing for me. So that is what that commit ID is showing. So how to resolve your merge conflicts, content merge conflict? You have to re-edit, confirm the changes, and again commit your changes and push. I'm modifying this one, so I'll take this is the main change. Okay. And
one question here.
Since
that is that through the web you have already committed it, that means you have pushed to the code.
Right,
Main
repository, remote.
main repository you have already pushed. You have run the pull here. That means it will pull the latest configuration.
Latest changes from the remote to my local.
And now you have to change that file.
I have to resolve my merge conflict myself. Why? Because now Git is very accurate. It is intelligent that can able to track the each and every change. But what nonsense we did, modified same file, same content by two different users in two different timestamps. She made a change I'm not familiar. And she pushed it, it's up to date as per her code change. I'm agree. But when I want to modify, I made my change. When I want to make my change, I'm keeping my name. When she want to make her change, she keeping her name. But before me, she committed remotely.
But don't like Git pull will override your configuration.
No, because that is what the conflict. Because what need to take same line two different people modified. What need to take locally? That is the reason her commit is coming with a commit ID. It's a confirmed change. My commit ID is showing as a latest header. If you are accepting this one, modify the change, recommit it and push the change. That is what now I'm modifying it. This is the final change I want it. And let's confirm this change. So you can see the Git status. So I have the change modified. So do Git add. So it's added. Now do one of the different commits, fine. So git commit -m. So saying that resolved content merge conflict. Okay, something okay, fine. So then git push. So it happened. Now see, git status is up to date and git pull, nothing is there. Okay, now see the remote. Remote, what will happen? Maybe you can refresh. See that it's supposed to update with my commit ID. It's supposed to come. Yes. Okay, this is what the intro, they'll ask you this question definitely. How you will resolve the merge conflicts. Auto merge conflicts will happen if you have a different content. It will happen with the commit, not a problem. But when you have a same content, same line by two different users in the different timestamps, then you will get that merge conflict, content merge conflict. You have to resolve it manually by verifying the content what need to be added newly, and you have to recommit and push. They'll definitely ask you this question. Got it? This is one key point. Okay. So try till here. Tomorrow again we'll discuss the Git part. This entire week is Git only bare. Next week we'll discuss the Jenkins. Okay, still we have branching strategies, lot of troubleshooting issues, lot of things are there here. Okay, we'll discuss that. Clear?
So one question. We were using git pull, right? So under
Right.
what scenario we will use git push? Just to enforce the code?
Yeah, I made some change. For example, as a developer one, I made a change in my component something. I confirm that changes. I want to push it remotely. Okay. Why I want to push remotely only? That is my main repository. Remote repository is the main. I'm not the owner. My company is the owner for that repository. As a developer, I'm contributing some code there and I'm pushing it. Later, my testing team will be going to test anyway. That is a different part. But I contributed that code. So locally, I made that change and I push it to the remote repository. The code will be stored there. Like that, all the developers, they'll be making their own contribution and pushing to the remote repository. It is not a centralized repository. Centralized means CVS. Ours is not centralized. It's a distributed. So it's a remote repository. So all the code changes will come and located under the remote repository. If any new developer comes or a new user comes, they'll clone it, they'll pull the code locally. Again, they'll start contributing. That is what the mechanism. Clear?
Okay. Yeah, clear. And is it necessary to make script.sh, or we can take any other name also?
Anything you take. Okay. Now I am writing the script.sh. Maybe you are some Java developer, you write some Java.any files, or Python developer, Python files, whatever it is. Ultimate aim is whether it's a Python code, Java code, parallel code, whatever it is a file. For me, it is a one directory, nothing but repository is a one directory inside one file. That is what we need to maintain that version control system by using that Git. That's what we are maintaining it. Inside the not script.sh, you write some app.java file or some app.python file, anything. It's up to you.
Okay. And is it necessary to make this GitHub to see all the changes? Because without this, we can't do this practical.
In my environment, I don't have GitHub.
Okay.
I have a one Git server.
Okay.
That is my bare repo. So in that server, it's a Linux server. So in that Linux server, all my developers, they'll generate the key pair, they'll share that key pair with me. Then I'll add that key pair to my server. Then they'll get access to this Git server repository. Then they'll clone with server URL locally and they'll start working on that one. Still we are maintaining that. And we are slowly migrating to GitHub. Okay. GitHub, what is the advantage? You don't need to maintain this server.
Right.
That is the advantage. Simple part. Okay.
Okay.
Clear?
Yeah, clear.
Yeah. Anyway, so we'll discuss still.
One quick question.
Yeah, please.
Sometimes we have seen the error code like head detached from something XYZ. If you go for the git status, so I have observed like head detached. What exactly that means?
Head detached.
It is happen when you manually delete any file from the
remote without maybe any git update.
File. Yeah. So index file is there. When you remove manually index file.
But it's a good thing or like we have to go back and.
You have to go back.
Its head is deleted. How will you commit? How will you push to the cloud?
It will not accept the next commit.
Push is not accepting even if the head is different.
Your ID?
How will it accept with no head?
Really, repository don't know
Where to push, where it should go.
MACHI. Not L. MACHI REDDY. DDY. SI. RE. SHA.
SHA anna. Not there.
Okay.
You do one thing, send me the code once you reach. Okay, I'll add you. Send me that codes, guys. I'll add you. Then you can get access. Okay. Try it. Okay. You'll get a lot of issues, not a problem. You do whatever it is, nothing will happen here. Okay. You clone it, do it, pushing and all those things. Only don't disturb the main branch. That's it. Okay. We'll see if you face any issues. We'll see. There I have a lot of issues earlier classes where people they're doing with nested repositories, lot of things anyway, not a problem. Then day after tomorrow, I'll explain you the branching strategies part. Then we'll see some concepts like merging, rebasing, and cherry picks. All those concepts we have that we'll discuss in detail. Okay. Now onwards, classes are important. Okay. So after this one, your Jenkins and all, it will be in the real-time things. Earlier classes, whether you learned or not is a different part. If you not learn that one, now it will be all new. You have to put extra efforts now. Now all commands only, that Git commands, similar like Linux commands. Later on Jenkins, again we have a scripting part, similar like our shell scripting, Groovy script there. Okay. Fine guys.
Answer.